Hello again, everyone. We are in our second and final acid-base lesson, and this is also going to be our last lesson for the year. So congratulations, you are almost finished with chemistry. All right, for this lesson, we are going to be doing a good bit of math, and it's going to be math that requires a logarithm button. So you need to have a calculator that can do log functions. So your standard scientific calculator should work for this, but I'll show you in a minute what I mean. We're going to be dealing with pH today. So something you probably knew before we even started learning about acids and bases is you probably are familiar with the pH scale. It's a scale used to express how acidic or basic a solution will be. Now, how this correlates with what we have already learned is that it is based on the concentration of hydrogen ions in a solution. So if you have a solution that is considered to be acidic, its pH is less than 7. If you have a solution that's considered to be basic, then the pH is greater than 7, and then 7 is our neutral point. So water, pure water, should have a pH of 7. Now, these next 3 bullet points I'm about to pull up, these are your little functions you're going to be using for the math equations for the rest of this slide. So you may want to jot these down somewhere. So this first one says that the pH is equal to the negative log of the concentration of hydrogen ions. So in a problem where you know the concentration, but you're trying to find the pH, all you have to do is type in negative log, whatever that concentration is, and you can find the pH. Now this next bullet point is talking about the pOH. So that's the measurement of the hydroxide concentration in a solution. And remember, that's coming from your base. So if you add the pH and the pOH, you should get a number of 14. And then this last bullet point is having to do, once again, with those hydrogen ions and the hydroxide ions. If you take the concentrations of both of those and multiply them together, then you should get 1.0 times 10 to the negative 14th. Now, just to show you how these last 2 bullet points correlate, if you take the negative log of 1.0 times 10 to the negative 14th, you're going to get 14. So we basically can use these last 2 equations as an either-or situation because they're both very much related to each other. Now, we're going to jump right in with some equations. I've actually printed off this next slide so I can walk you through how to do these. Okay, here we go. Again, you need your scientific calculator, and I'm going to copy down those functions here at the top of my sheet. First, pH equals the negative log of our hydrogen ion concentration. And then pH plus pOH equals 14. And then the concentration of our hydrogen ions times the concentration of our hydroxide ions equals 1.0 times 10 to the negative 14. Now, this last equation I don't really use as much. I mainly use these top 2 when I'm solving my problems. All right, so the first question says, calculate the pH of an acid in which the hydrogen ion concentration is 8.3 times 10 to the negative 6. So we're supposed to be finding the pH, and they've given us the hydrogen ion concentration. So all you have to do is plug that number into the equation. Negative log 8.3 times 10 to the negative 6. So in my calculator, I've got negative log 8.3 e negative 6, and I get 5.08 as my pH. And we're done. Easy as that. All right, for the second problem, it says calculate the pH of a solution in which the OH concentration is this number. So, since it's not the hydrogen concentration, we're going to have to either use this or this. So you can do one of two things. You can divide this number into 1.0 times 10 to the negative 14, and then you will get a POH. So at that point, you just subtract it from 14. Or you can go ahead and plug in this number, do negative log of this number, and just keep in mind that you'll be getting the POH of that number, and then you need to subtract that from 14. So either one works. I'm going to show you both just so you see that either one can work. So we'll start here. So the POH, I'm going to specify POH is equal to the negative log of 4.0 times 10 to the negative 6. So let's see what we get when we do that. Negative log 4.0 second E negative 6. All right, so we get 5.4. And then remember, since that's the POH and we're trying to find the pH, I'm just going to subtract that from 14. So 14 minus 5.4 gives me 8.6 as my pH. Now, like I said, I'm going to show you the other way you can do it. You can also take 1.0 times 10 to the negative 14 divided by 4.0 times 10 to the negative 6. Let's see what, sorry, you can't see that. Let's see what you get when you do that. Okay, and so once you do that, we can take, let's see, the 2.5 times 10 to the negative 9. Now we can take the negative log of that. So negative log, and we get 8.6. So whichever one you prefer to do, you get the same number no matter what. I typically prefer to do it this way. I go ahead and just anytime I see a concentration like this, I go ahead and take the negative log of it. And I just keep in mind, like in this first example, when I did that, it was the concentration of hydrogen ions. So when I took the negative log, it's the pH. For the second example, when you take the negative log of this, it's the POH. So you have to subtract it from 14 to get the pH. So like I said, this is my preferred method, but just so you can see how this other equation can be useful, either one of these works. Okay, problem number 3. The pH of a solution is 6.3. What is the hydrogen ion concentration? So now we're doing the opposite. This time they've given you the pH and we want to find the concentration. So rather than using the log button, we're going to have to use the anti-log button. So it's going to be the anti-log. And where do we incorporate that negative? You're not going to type in the negative anti-log. You're going to type in negative whatever this number is, 6.3. So on my calculator, that's just a second function, second log, negative 6.3. And it gives me 5.01 times 10 to the negative 7. And I don't have to do any addition or subtraction because this was the concentration of hydrogen ions and I'm finding the pH. Now for my final example, it says, what is the POH of a solution with a pH of 3.7? All right, so you can see here that we're dealing with OH and pH. So you can use either of these functions like we did earlier. I'm just going to do the one that I typically do where I subtract first. So 14 minus 3.7 gives me 10.3. and then I'm just going to take the antilog of negative 10.3. Let's see what we get. And I get 5.01 times 10 to the negative 11. Okay. Now, the next few slides of this PowerPoint are more practice problems. And these practice problems give you the answers next to them. So I'm going to let you do those on your own since you are given the answers. But as you're working through those, if you have any issues, you're like, I don't know how you do this one, please contact me on Remind and I can walk you through it or show you my work. But it's really just more of the same thing that we just did together. All right, so I'm going to go back to our PowerPoint now. These are the problems we just did. These are the practice problems with the answers in parentheses. All right, now this next slide is about indicators. If we were together, we would be doing an indicator lab to demonstrate this slide. Basically, there's just a lot of indicators out there that tell you either the exact pH of a solution or a range of pHs based on color changes. In the lab that we would have done, you'd get to explore those different indicators and see which ones are the most accurate. What you find is that some of the indicators are specific for acids, some are specific for bases. So they give you a particular color that you can tell exactly is that acid's pH or that base's pH. And then you've got very simple indicators like plain litmus paper that turns blue or pink to indicate if it's an acid or a base. So that's not going to tell you the exact pH. It just tells you sort of the range of pH. But indicators is going to come into our next discussion, which has to do with titrations. Now, I mentioned titrations at the towards the beginning of the year when we were learning about lab equipment. I told you that a burette, or a biuret as it's often called, is the instrument used for titrations, and it's a very, very accurate piece of equipment. And it needs to be, because what you're doing is you are adding a controlled or measured amount of base to an acid or acid to a base. And the purpose of doing that is to determine the concentration of one of those. So you're going to know the concentration, for example, you're going to know the concentration of the acid. You're not going to know the concentration of a base. So you have to do a controlled measurement where you add one to the other, and you'll do some math to determine that unknown concentration. Now, what you're doing is you're trying to reach an equivalence point. What that is, it's a point where you have reached neutrality. So all the acid and the base has reacted with each other, and you have reached a point that is neutral. So it's called the equivalence point or the end point. That also means that the moles of acid and the moles of base are equal to each other. So a definition you'll often see is that the acid and the base are chemically equivalent. So that just means if you multiply the molarity times the volume, you would get an equal amount of moles for both. Now, how are you going to be able to determine that? That's where the indicator comes in. So before you even start adding that acid to the base, you also have an indicator within the base. Or again, this can be vice versa. And you'll start to add the acid, and you'll see the pH slowly change. And then once you're reaching the equivalence point, it will rapidly change. And then you will see the substance turn a color, and it won't go back to the original color. And that's when you've reached the end point. Now, obviously, we can't do a literal titration problem together, although you will be doing a simulation with the acid rain labster. We are going to practice doing some titration problems. And actually, we've already done one together in our solutions unit. I didn't tell you that's what it was, but you basically have done this math before. So real quickly, this is a combination of your molarity equation and stoichiometry. So you need to write a balanced equation, use your molarity formula, which is molarity equals moles per liter, to solve for moles of that acid or base that was added. And then you're going to use a balanced equation to convert the acid to the base, or vice versa. That's where the stoichiometry comes in. And then you use the molarity equation to solve for that unknown concentration. Now we're actually going to do this a little bit simpler than what you just read, because we can also use our M1 V1 equation to solve these problems, and I find that it's a lot less complicated to do it this way. So once again, I have printed off this slide, and we're going to work this problem together. And it says, suppose that 10.1 milliliters of nitric acid is neutralized by 71.4 milliliters of a 0.042 molar solution of calcium hydroxide. Calculate the concentration of the nitric acid solution. Okay, so in other words, you know the concentration of the base, you don't know the concentration of the acid, and you're performing a titration to determine that. So, starting with a balanced equation, we have nitric acid combined with calcium hydroxide. Those are going to neutralize each other to make water, and then the salt you get from that is calcium nitrate. This is a double replacement acid-base reaction. And then to balance it, you need to put a 2 in front of nitric acid, and then a 2 in front of water. Okay, I like to write down everything I know and everything I don't know underneath the formulas. So underneath nitric acid, I'm going to write my volume is 10.1 milliliters, but I don't know the molarity. Underneath calcium hydroxide, my volume is 71.4, and my molarity is 0.042. All right, so I'm just going to use my M1 V1 equation to solve. All right, so 71.4 times 0.042 divided by 10.1, you get 0.297. And then don't forget to do the stoichiometry part of this. You're going to put the unknown on top, so that's a 2. The known on the bottom, that's a 1. Where am I getting these numbers from? I'm setting up a mole ratio. That's coming from the coefficients. Unknown over known, 2 over 1. So if I multiply this number I just got by 2, I get 0.594 as my molarity. And that's the answer. Okay, so again, a titration is when you use an acid or base of known concentration to determine the concentration of an unknown acid or base. All right, so back to our slide. I'm just going to quickly show you. This is just the same thing, just a different way of doing it. If you wanted to use the molarity formula to solve. Again, I think the way I just did it is a little less complicated, but you notice that you get the same answer, 0.59. All right, and then you'll notice that there are 3 problems here. And next to these problems, the answer is in parentheses. I'm going to put my work here. I expect you to try these on your own, but if you get stuck and you're like, I don't know how she got that answer, I'm just going to show you my work. And you can pause your video here to look at this sheet whenever you need to. All right, and then a couple other things. Continuing in this PowerPoint, now you're going to do these bookwork problems on page 504. And then you'll also notice on this PowerPoint there's a quiz. You don't have to worry about the quiz. Had we had more time, I probably would have given this to you, but no worries there. So you can stop on slide 17. And then the last thing I want to show you, just in case you need it, is if any of this was complicated or didn't make any sense, you can look at your interactive reader. This is chapter 15, and that starts on page 480. Now, there's a lot of information in here that I did not teach you because, again, these are mini units. We've only spent about 4 days, 2 lessons in this unit and the solutions unit, but it goes through, these chapters go through all the things I've taught you. So if you want to flip to the discussion about titrations or the discussion about pH, this would be a great reference for you. Okay, so you have your bookwork and you have your Labster, and then you are done with chemistry. And guys, I miss you. I wish we could have finished the semester together because there's a lot of cool labs we could have done. But I encourage you to take AP chemistry and you'll get to learn all of this again, and you'll get to do a lot of cool labs along with it. All right, so let me know if you need any help. I'll see you guys later.